Good morning once again. Welcome to the data science course conducted by IIT Guwahati. So far, we were discussing about the convolutional neural networks, which are the fundamental tools considered as a part of the deep learning, and we will be moving ahead to the application related to the computer vision that's going to start today. But before that, we will be looking at some of the example codes, uh, how to implement the various neural networks for a specific application. Right. So far, we were looking at the PyTorch version of the codes most of the time. So I want you to get introduced to the writing codes for a image classifier, right? That is using Keras, right? So that's what we are going to start with in today's session, and later on we'll move ahead to the computer vision. Okay, all right. So I'm going to share you one code right away, right? So that's the one which you are seeing here. Right? I just want all of you to run simultaneously, and right, we'll consider the variations in our results. Also, we'll discuss about that. Okay, so you'll be getting a file. Okay, in the chat, kindly download and paste it in your folder where you normally run the Jupyter. Okay, so that's a requirement from my side for before we begin the session. Okay, so everybody, please take 1 minute of time to copy this into the particular folder and open this in the Jupyter or even in the Colab. I think we should be fine. Okay, whichever you prefer, kindly open over there. All right, so we'll start the discussion, right? Meanwhile, once you have that, please start running the code cell by cell, right? While I discuss and we'll go step by step. Okay, so here our intention is to look at the Keras version of coding, right? So previously we were looking at the PyTorch version of classification or examples. Or right, initially we did with the TensorFlow, right? Then we moved to the PyTorch as well because uh, normally we consider PyTorch, uh, TensorFlow, and the Keras are the most famous tools or the libraries which people prefer whenever they try to code machine learning, deep learning, right, related problems. Maybe it is a classification problem or a regression. We'll move on to. We'll commonly use these three. Okay, so I want all of us to be familiar with that. So I'm trying to give various examples. So in this case, we consider a particular code where we try to classify the image, right, using the Keras. Right. So initially, the first cell is about importing various features required, various modules required. So the first one is we are trying to import Keras from the TensorFlow. So there are two versions, right? Which commonly people use for in the programming. One is that you can directly import Keras. That is also good to work. Otherwise, you can import Keras from the TensorFlow. Both are going to work fine. There is no difference, right? But the way of programming is different from in different perspectives. So both are going to work fine. Okay, so if you simply import Keras, right? That's going to work fine. Otherwise, we'll do from the TensorFlow, you import the Keras. Okay, so I think we have discussed one point earlier. That's about the building of the Keras was actually upon the fundamental building blocks of the TensorFlow. So that's why here normally we prefer calling the Keras from the tensor. Right. So again, those who are familiar with the TensorFlow and those who are using the TensorFlow since long time, you may be aware of the fact that right now we are using the TensorFlow version 2. Okay, before that we had the TensorFlow version 1 where the Keras was not there, right? Or partially it was built, some of the functions, right? In the TensorFlow which version 1, right? Some of the functionalities are right, a part of the TensorFlow only. Because there was no Keras talking about. So most of the functions, most of the layers which we define, right, etc., where you were able to directly import directly from the TensorFlow libraries. But when the TensorFlow 2 came into picture, right, there was the Keras was already built, and Keras is actually a higher version, right? It's like on an upper layer of that. So wherein you don't get a chance to look into what's exactly happening inside. You can simply call a function; it will do the job for you. Most of the people, including me, when I want to implement something, I don't want to look what is there inside, what exactly is happening inside the function, or from scratch we don't want to go. We simply want to call a function and we want to get the things done, right? In such cases, now also Keras is the best suited, right? I'll demonstrate that later. But the concept I want to teach right now is that now the TensorFlow, whenever we install, right, or whenever we call, or whenever we import TensorFlow, that comes into picture, or that comes into the memory, is the TensorFlow version 2. Nobody goes for TensorFlow version 1 because it's older. So in this TensorFlow version 2, the change is that there is already Keras and there are many functions, many functionalities, many sub modules that are present in Keras. They have removed from the TensorFlow because it is already available in the Keras. So now what our intention is that though you want to go for the TensorFlow based programming approach, right, you may have to import the Keras as well. Okay, this is not related to our today's discussion because anyway our intention is just directly to use the Keras. But if you search, say, let's say I want to write a particular code in some perspective, I want to solve a particular problem, right? You will search in Google saying that okay, TensorFlow code for something. You may get an option, right? You may get several options, but you will see that people use Keras over there. Now you may have a doubt that no, I want to do it in TensorFlow, but why the Keras comes into picture? Why people are importing Keras? Right? I'm trying to answer that question now because TensorFlow 2 uses some of the modules, right? They have removed the original module from TensorFlow 2 because it's already present in Keras. So you may have to bring some of the modules, some of the sub-modules from the Keras. So now when TensorFlow 2 is being used, if you are writing a code in only purely TensorFlow, still you need to bring the Keras. That's what is the importance of Keras now. So maybe you will search for some code, you will get a code, though your intention is to do the coding in only TensorFlow, you may have to incorporate the Keras as well. Okay, some part, but fundamental operations you still can do in the TensorFlow because that's the basic building block. Okay, fine. So here we are bringing the TensorFlow and as well as the Keras, right? Directly you can import the Keras. Then we have to specifically which models you want, you can bring them. So from the models, right, we want to go for a sequential, right? So initial classes on the TensorFlow, we looked at the building up of the various blocks. How do you build the various neural networks, specifically convolutional neural network, then going for pooling, then maybe a dense network, etc. We used, right, the sequential model one after, right? So in that we need several layers. So right, so you see these are the various layers which I felt yes they are needed for our example. So anyway, so every word you should be familiar by now because we have taken up each and every topic separately and we have discussed in detail. So there is a dense layer, dropout layer, flatten layer, convolutional 2D, max pooling 2D. Right? Other than this, if you want, yes, you can definitely bring in. Then there is a data set available inside the Keras itself, right? So various data sets are available, out of which we are bringing the one particular data set. then NumPy, then we want to use some of the utilities under the that are supported under Keras. So okay. So first directly let's go to the data set separation. So there itself, it is already made available in such a way that when I use mnist dot data load, right, it actually separates the data set into the training as well as the testing data set. It is already present in that format. So otherwise, normally when we collect the data, it is expected that you will have to do some data munging, right? You have to process the data and convert it into the format, right? So we have another option of bringing the scikit-learn over there, right? From there also you have train test split option is there, right? Many options are there, right? Whichever is possible, whichever we are familiar and we are comfortable, we can go with, right? But here it's already available, so we don't have, right? So
I have one question. What is the type of this MNST data? Like what type of data it holds?
Yeah, it is image data. Okay, it contains image data set corresponding to the handwriting recognition. Right, so there is, it's a 0 to 9 written, right, handwriting data. So 0 to 9 total 10 classes. All right. So again, it is it's a handwritten data set. 60,000 we have individual count. Okay, totally there are 60,000 data. Okay. So now the Keras prefers data set to be present in this format. Each and every point, right, we try to convert them into a specific format. Okay, so we can use as type, right, that will convert irrespective of what format it is into the floating value 32-bit representation. Right, now you can see if I look at the shape, 60,000, 28 comma 28, that's the size of pixel. Right? So each matrix which we represent, right, is 28 rows, 28 columns. It's in the binary format, so zeros or ones are. I think we have used this data set once earlier, maybe the initial session somewhere when we started with the TensorFlow or the first part, right? We had done one part of the code, but not using this technique, using a different approach. But the data set I'm going to use here is the same. So meanwhile, are you able to run the code on from your side? I hope it's running from your side. Okay, so let me know if you feel like, if you want to give any inputs. Okay, so there is one standard approach is to after you read the data, right? The pre-processing comes into picture. The normal technique is that you perform what is called this, right? So normally we bring it into the normal distribution, right? The data set data points to be present, whatever values we have. That's one way of pre-processing. Right? Instead of having a wide range in my data set, we'll try to convert that into a normal. So the normal distribution should be, right? If you remember the equation, x minus mu divided by the sigma, right? So you see everything, x training data set, we perform that. So x train value minus its mean value, divide that by the standard deviation, that's a sigma. So we repeat that for training data set as well as the testing data. Normally, it is observed that when we don't go for this step, there is slight variation in the overall performance, right? That's why the normalization will be used as one of the standard technique in the pre-processing step. But again, this is optional. If you are okay with slight reduction in the final accuracy or something, right? It's okay. You can skip that. But this is what I want to show you that we can involve this because this is one of the pretty standard techniques. Right. Then specifically the image data set. All right, because there may be variation in terms of, because I might have collected the data from various sources, right? So various sources referring to various types of cameras, or right, mainly cameras, because the settings of camera, you may be taking the image or the photograph of the same object, but if I use multiple cameras, right, maybe the characteristics of the image, the range of the colors, the brightness value, etc., will definitely affect the data set, right? So in order to bring them under the same what you call category, right, of same range, etc., this is what is going to help. Now, the y value, in the sense the expected results, the target values, normally they may be in the form of numbers, numerical characters, numerical values, or the letters, okay, etc. Many other formats are possible, but what we want is to bring them under a category called a categorical data, right? So that can be performed by using the NP utilities of, right, there is actually a function, right, to category, that is actually present under the NP utils, right, of the Keras. So we have to use that. So convert y train and the y test, right, make them into a categorical variable, so that even though there is a text data present like NINE, ONE, etc. written, it gets converted into a categorical data. So now the data set has 10 classes. Corresponding to 10 classes, we have 10 categorical names created over there. They are no more text, right? Though it is written in the text like NIN, ON, everything will be a categorical object, right? So after that, we'll print that and we'll observe that the total number of classes in this data set equal to 10, right? So once again, we are testing the x train dot shape. I think already I had written that. Maybe I was checking it here once again. Right now we'll move on to the sequential model creation. Just try to recall what we already had discussed about the sequential model creation under the deep neural network concepts, right? So initially you have multiple options to create the models. Initially you can decide and you can write inside a square bracket, like you can make a list of various models. One option is that various layers. And the second option is that you create a model, you declare it as a sequential model, and keep adding the various layers which you want. Okay, so yeah, so when you run, right, I want to do two things, right? First, we'll go with this particular model, then I'm going to ask you to change something so that you will learn, right, what are the effects that we already have studied when we discussed about the theoretical aspects of the convolutional neural network, right? Is it going to happen? Is it going to work out or something? We'll check that. Okay, fine. So first thing, right, let's look at the model's structure, right? So initially, I'm declaring that I want a sequential model. So it creates a sequential model. Now you see model dot. So in the standard of the state of art models we studied, always they follow something very similar. Right? So you have an input layer with input neural network, input neurons. They pass the sensed samples into the first layer, which is going to be a convolution layer, followed by a pooling layer. Right? Convolution pooling can be repeated any number of times. Each time you repeat, more and more features are going to be extracted. This is what we have discussed. So now we'll see that. So it's a convolutional 2D layer, right? You are free to choose the number of filters. So the 32 written here is that I want 32 different filters. Right. Again, 5 says it is the size of each of the filter. 5 means it is 5 cross 5. Right? You have an option to enter that inside the as a list. Okay, you can make it a list like square bracket 5 comma 5. You can write instead of this 5. That is also going to, right? But we prefer this. Just say 5. It means it will automatically takes that as a 5. Now I need to specify what is the size of the image that I'm going to keep, right? Just now we saw that there are 60,000 images of 28 cross 28. So this is 28 cross 28. I will say 1 because it's a black and white. It's a binary image. Only zeros or ones are present. And then you see I'm saying that, okay, activate the ReLU function. Right. So we had discussed the same thing. Why do you need ReLU? We know that, right? In order to, right, make sure that the error, whichever is going to be calculated, which is required for the updation of the weights of each of the layers, will be propagated only if you use a ReLU. Or other versions of ReLU, which we have not discussed. There is a leaky ReLU. There are other versions of. Okay. So anyway, so let's stick to what we have discussed so far. So ReLU is going to be used. Next, you see After immediately after this, it has to be followed by a pooling layer. Now we are using a max pooling. So max pooling 2D because the function is a two-dimensional, or a variable which we are passing is a two-dimensional as it is image. Okay, so you just have to tell the pool size. You can simply write pool size equal to 2. That will work. Okay, so I showed you the other option also. You can write like 2 comma. So that finishes my first layer, convolution plus pooling. So right, initially I ran this code with only this set. I slightly got a lesser value of as accuracy, right? We'll do that later, but as of now, I'm telling why I inserted another set, right? So another set of convolution 2D plus max pool is added here because when we ran with the first set, lesser performance. Okay, lesser performance in the sense the accuracy was lesser, indicating that weight operation was not taking place in a sufficiently large manner, so that it is optimized to the for the classification of 10 classes, right? So normally this is a convention. Again, you don't have to follow this, right? Convention is that whatever you write here, take more than that. Okay, in the next layer, if you are adding another convolution followed by a pool, right? This is because now already go back to the basics, right? Where we have discussed about why do you add another set of, when you add another set of layer with another set of filters in the convolutional 2D layer, you are trying to extract more and more features from whatever image that comes, right? Whatever feature map or whatever is the output of the previous pooling layer, right? Now you want to see the previously I used say 32 filters and I am not able to classify this data set properly, means I should extract more feature. Okay, so more feature means you have to use more filter. That's the fundamental idea here. Normally this will be a 2 to the power number. Okay, again, it's not necessary you have to stick to that, but the convention is refer to any of the standard codes of the standard CNNs which are available in the internet. They follow this, so we are trying to keep the same standards. We are trying to follow that standard architecture. That's why I have written here 32, 64. If at all I'll add another one, I'll go for 128, 256, and so on. Right? That's a convention. Not necessary you need to follow. You can change, still works. All right. So so that's how it is written here, right? Activation function is relu, right? Keeping the pool size same, definitely you can change. All right. Now you see we go for a dropout layer, right? If you remember, right, whenever there are so many connections, so many weights to be updated in case of the convolutional neural network, right? In order to reduce the computational load, okay, and in order to reduce the overfitting, two things, right? We go for a dropout. So if you remember, there is a range given for the dropout, right? Refer to the previously given notes where you will find that the range normally is between 0.2 to 0.5. All right. So normally we start with the 0.2. Again, I'll tell you what to do at a later stage. I want you to change this and understand what happens with the training process and what happens with the accuracy later, right? So one option here, right? Immediately after you finish the convolution pool set of, right, those layers, you go for one drop. That's what is standard, right? You can give a number 0.2 or 0.5, right? When I did, I started with the 0.5, thinking that let me reduce the computation load by a drastic amount, but that was not working. 0.5 gave me a lesser accuracy. Then I reduced that, right? Then at 0.2, I find that okay, this is better. Okay, only that thing. Then right, go for a flatten, right? Flatten because my next layer is going to have 250 neurons, but the image size, whatever I'm going to get here, will not be of that size. So when you have no idea what is going to be the next layer, and I don't know how to do the reshape, right? So that's why you see the Keras is easier, right? If you go to other techniques, you need to see that okay, what is the format, what is the exact shape I need to I need to reshape my present tensor so that I can pass it to next. You may have to decide, right? But this is a flatten layer. Simply add the flatten layer. It will automatically do the job for us. It does the job for us, and it will, right? Next, my layer is a dense layer in the sense, right? Fully connected layer. So look at the standard architectures. There will be 1 or 2 or 3 dense layers connected, right? So in this case, right, there are, right, 2 layers of dense, out of which the last dense layer we are defining is the output layer, right? The one which we are connecting next to the dense layer, which is defined here, right? So that will be the final layer of the output layer. So you see here, again, this is optional. Normally we use just before the output layer also, you can use a dense, sorry, not dense, my mistake, a dropout, right? So because there are so many neurons, in this case it looks like smaller number 250, but in a later stage when you when you try to solve a much bigger problem, right? So this data set is actually considered as the initial data set which which people use when they learn something. But if you go to the ImageNet or some other standard what you call data sets available, you will find millions of data, millions of what you call images over there you may have the classes of number of classes is not 10, like 1,000, 10,000. Okay, maybe I'll try to share you one document which contains at least the names of the standard data sets which you can use. Okay, that's not included in today's session, but I will send you separately. Maybe it's available when it gets updated to the elements. All right, so it will, right there you will get an idea that okay, what are the standard image data sets that are available which you can download, you can work on. Fine. So in such case, we will not be having a smaller number here. You may have to go beyond, say, 10,000, 1,000, 5,000, etc. So wherein definitely, right, you have to use a dropout because updating so many rates will be a computational burden for the machine, right? So in such case, right, so we have to go for a dropout, right? 0.2, 0.3 work in a very similar format for me, so I went for 0.2. All right, so anyway, it will definitely change when you run on your machine, right? Slight variation will be there. So final layer is a dense layer. Again, you see how many neurons you require. It is equal to the number of classes. Already we declared, we have calculated that is equal to 10. So 10 neurons, and remember we need the softmax because it's a multi-class, right? When we have a multi-class, what is required? You try to recall, only one of them should be high, all the others should be low. Only one activation function can do that, right? That is the softmax. So we use that. Then final output shape I'm trying to print out, so that comes to be 10. So there are 10 outputs. The next concept is that you need to mention what are the parameters you want to incorporate when you do a training, right? Every time you train, the fundamentals still remain same. I have an output calculated, say y. There is a desired value d. D minus y is error. Either you use the error as it is for your weight updation purpose, or apply some algorithm. Using that algorithm, you okay. So using that algorithm, you can go ahead, right? So algorithm based or directly calculating the error, etc. It still remains same. Just try to recall how we went step by step in the previous classes. Okay, now you see, first thing is, right, you have to perform what is called as a compilation. We have a question before that. I'll answer the question and come back. So are we using the dropout in the output layer? Not in the output layer, right? It's just before that. Okay, so every connection that is coming to there, you can perform it because there are so many tens in the previous layer, right? Okay, so previous to that, we are trying to drop over the connection. Okay, sure. So the next procedure in the Keras is to perform what is called as a compile, right? So it's called as a compiling your model, right? Already we created the model. I just have to specify the 3 things at least. There are many other options. right? You can go to the help and you can find the other details of this, but I suggest at least three things you use. One is called as a loss function we have studied, right? So, right, one is a squared error, right? You can use the J term in the previous notes. If you see that, there are two equations given. First one was a squared error. Second one is called as a binary cross entropy, if you remember, right? So log based functions. So you can use that. So again, we never discussed the categorical cross entropy. It's another equation, that's all, but works on the fundamental principle of the binary cross entropy only, right? It works in such a way that we call the binary cross entropy. Whenever desired value is 1 and you get a 0 as output, you have a highest value of the. Similarly, if you have, right, the other case also, in the sense desired value is 0 but output is 1, still you have a highest value of j coming to picture. That was only when you have two classes. So the name of that particular function was binary cross entropy. In this also you have binary cross entropy. Simply replace this by binary underscore cross entropy. You are bringing the binary cross entropy into. But that is suggested when you have two classes. Since the number of classes are more here, simply change it by the categorical cross entropy, because we have many categories. That's all. Okay, that's one thing. Then look at this SGD, stochastic gradient descent. You understand now what do you mean by SGD? I am updating the weight every time. Go for others, right? Everything we studied, bat, mini batch, everything is available here, right? We can change that. So how do you check what options you have? Simply go for model.compile, right? Type that in a new cell, put a question mark, okay, after that, and enter. It will give you the details of that. Otherwise, you can also go to the help Keras and you can go for a compile section over there. It will give you complete details. What are the various options you can give here? It's not only loss optimizers, matrices, you have many things more, but these are the three things which I suggest you to keep. Otherwise, it will take some default. You may not reach the accuracy which is something like 90% or 95%. We may not reach that so easy. Okay, so I suggest, right, from the basics what we already know, right, use them properly over here, and you, right, you will be able to attain that required accuracy much faster than the default one. Okay, then the metrics, how do you want to measure the accuracy? You have what is called as simple accuracy is also going to work. Categorical accuracy is what I suggest when you have multiple classes. You have one or two classes, three classes, simply you can write only accuracy. One and same, right? Slight change in the formula which is being used for the calculation purpose. Okay, other than that, no difference. You use accuracy, still it works. All right, so that's what is the compiling of the model, right? I need to specify, right, how do I want to proceed, what are the various hyperparameters I want to calculate, right? So one set is the weights, which is already being defined and being used over there, and the other matrices or metrics which we want to use, right, you can define when we go for a compilation procedure. So that's the second step normally we will be following. Okay, so when you are free later, go on search in internet and find some standard codes, right? There also you see the similar modules coming one after the other. Okay, right. Then the next step is to go for a fitting of a model. So model.fit is the function which I'm going to call. Just tell, right, inform which is your training data. First data will be training. Then what is the target? Whenever I train, what is the target? Then if at all you want to perform a validation, we have options here. I will come to that option here. But now you see that I am giving the test data itself here. Why? There may be a question. I'll come and I'll answer that as well. But you see, the steps are like this. Okay. So validation data, if you have, you specify what is that. What is the data and what is the class? In the sense, X test and Y test. Y test is what we have separated, right? Which normally in this case, the test data is completely different from the training data. So training data 60,000 images are there. In this case, the test data is 10,000. Okay. Normally, again, it varies from various researchers and their opinions. And if you find the what you call the sorry, if you find the various the references, there you may see a variation in terms of the number of data you use for test and the train. So there is always uh, right different opinions over there. Normally 70%, 30% or 80-20, right, is what people normally use. But always there will be a discussion about what is the ideal value over here, right? You will see that people doing the experiments with 50-50, right, is also there. Okay, but normally we expect machine to get trained more than the testing part. So 50-50 is normally not suggested, but anyway, you can find a lot of work with the uh, pattern in which you give the you split the training and testing data. Okay, other than that, so you see, these are the parameters you need to pass. What is the training data? What is the target? Then if you have a validation data, yes, you can give number of epochs, right? And the batch size, right? So whenever I want to divide this into batches and I give train, you can mention that here, you can vary the size. Okay, now coming to this part, you have option like out of my training data, I can separate them. I already have, say, 60,000 images with me. That's going to be the training data. Okay. That you separate 50,000 and 10,000. So every time you train, you can go for one, you take one image from the validation data and you test, right? Whether the learning is proper or not. So in such case, whatever is the variable name, you can pass. Okay, maybe X val and Y val. Let us say we created that and we can do that. That's one option. The second option is that you don't have to go for a separate testing at all, right? Give the testing data itself as a validation data. So it's a kind of testing, may not be a proper way of testing, that's for sure, but I can save some time. I can just get to know that, okay, what machine has learned, what is the approximate accuracy I might expect from this. I can come to know, right, without doing the proper testing separately after machine learns something. So that's why I have passed the test data itself over here. It's optional, right? I got various comments saying that no, you should not go for this, right? Because you may want to do it separately. Yes, that's the normal way of doing the testing. But I want to save some time. Let's see. Okay, because this training took, let's assume that there is a training process which takes 3 days. After that, people want to go for a testing, right? Just you can avoid that by doing this. My intention is just to know that what is the accuracy I will get on if I work on the test data. For that, you can save some time if you do this. Okay, you can pass the test data itself as in the form of a validation. While validation is basically a type of testing. Okay? So whenever a data comes, so new training data comes, machine is going to learn something. Immediately after that, I'll take one from the testing data and I'll test whatever the learning is proper. That's what is going to happen. So we have options, right? From the training data separate, keep something separate, not used for training. But as soon as training happens, one batch is trained, you give one from this, test that, whether it is done, call it as a validation. All right, so that's what is happening, right? Again, so as you see here, I am passing the testing data itself here, right? So as soon as I run this particular cell, you can see that, right, the training happens and we can observe that the validation accuracy keeps on increasing ultimately, right? Loss keeps on reducing and accuracy keeps on increasing. And the final accuracy which we are getting is approximately 98.86. Okay, so right, so this is what I got when I ran this code. Right now, you also I hope you are running from your side. Okay, so whatever accuracy you are getting, please put those values in the comments. Okay, so Snake says, yeah, okay, 99.02, right? Error is 90.98%, close to 1%. That's okay, absolutely perfect, right? So Jyoti says 98%, 98.9, close to 99. Yes, that's good. Anybody? Meanwhile, we are open for questions. Any oral questions are there? Please ask them. We'll solve those doubts and then we'll proceed further. So Nilesh says 99. I think that should be 99. Oh, yeah, okay, 99%. Good. Okay, so Nitin is getting 98.97 accuracy. That's good. All right. So again, as of now, what we are discussing is the general way of writing the code. What block should become? What should be the flow in which you will write? Take any data set, right? That's going to work, right? So the initial part is the collection of the data, reprocessing the data, converting into the proper format, looking at right what are the columns I require, etc. That has to be done before we start this. Okay, so that is one important aspect. Once that is done, then the coding is nothing. Now you know that, okay, just write this particular code and make modifications, keep modifications in this so that you keep getting the better results. Okay, I'll come to that. Meanwhile, I think we have a question.
Yeah. So
Yeah.
one question, we have done the normalizations, and we are using the formula. Instead of that, there are standard the scaling and the normalization.
Yes.
Yeah. So can we use those standard
Yes.
scalar and
Yes, definitely. Yes. Okay. You can use any of the normalization techniques, right? That is suggested, right? You can use every method has its own impact on this ultimate final accuracy which you are going to get. Some may, right? Some of the methods may give you slightly lesser value. If you don't do, you may get a least value. It will not bring it down more than say 2-3%. Okay. Even if you don't do it, it will come around 95, I guess, for sure. Okay,
yeah,
so
thank
other
you.
methods will definitely have its own effect, right? So slight variation will be there. Okay, so again, we don't have a specific method or specific thing. I cannot say that, okay, you have to go for this method only, okay, for normalization, because it depends on the data set, right? So I just want to show that, okay, there is what is called as a normalization. You will have to do it this step. Okay, so you can use any other methods at that particular cell. All right. Okay, so any other question? Okay, so SGD and the batch size, right? So SGD says that, right, we are going to update, right, the weights, right, at every, so that's the stochastic gradient descent technique. So when I after declaring that, if you say the batch size, batch will be used after 60, there will be a page. Okay, so that's what is going to happen. So if I say SGD, it is expecting to update the weights after every train. But if after that, even after that, I say there is a batch size required, so it will apply the batch size only. So 60 images will be considered, and after 60 images only there will be. Okay, so I'll come to that now. I'll try to make another point clear here. Now you see, so the batch size is defined 60. So total, how many images we have? Totally 60,000. So you see the in epoch 1 out of 10, right? You can see here, it is 1,000 out of 1,000. How it decided 1,000? There are 60 images going into the machine at once. It is repeated how many times? 1,000 times. So 60 into 1,000 is 60,000. Now what you do, you can make a change here. Increase this to maybe a different number, bigger number, 600 or even 6,000 maybe, right? Try that, okay? So if you do that, one change, right? You observe something here, okay? What is that change? You tell me. Okay, so everyone, please change this number, make it a bigger number. Okay, so when you make it say 100 to go to a bigger number, say 500, 600. 600 will give you a proper number because there is it will be 100 iterations. Okay, in each epoch you are going to perform 100 iterations. when you enter 600 over there, right? Definitely there will be change. You may have a change in terms of the accuracy, right? Basically, because the training happens in slightly different way, right? So because of that, you may find something different. Okay, so everyone change this to a different number, bigger number, not smaller. If you reduce this, more number of iterations will come into picture. Not suggested. It will take more time. That's all. So now I just want you to understand the use of this batch size. What is the effect of this batch size on the training, right? And the training time. So increase this to a larger number, 600, 1000 or something like that. And look at the values you get on, or the look at the values you get over here. Okay, so just once you are done, please put that whatever value you get, whatever the number of iterations. I think that is a straightforward calculation. Simply 100 will come. Accuracy wise, what is the change? You please tell me through the chat. Okay, meanwhile, any other question if you have, please let me know.
Sir, this optimizer and this schemes, they are different or the same? Like optimizer, we have used, I think, one Adam and this SGD,
Yes,
Adagret.
yes,
And the
yes.
schemes are the different, how we are sending the data, like in batches or this row wise or
Yeah,
same? Are they same?
it's the same. It's same. It's same. You. They are all categorized into the same. What you call They are called as optimizer under the Keras. You can specify anything over here. Okay. So if you want to go for a mini batch, right? This is a mini batch. Simply say that batch size equal to 60. If you say batch size equal to the complete data set, it becomes a batch process. Okay.
So, sir, this is as we are sending, which scheme we are using here? This batch scheme or like SGD scheme?
No, SGD, you have an option for specifying. Now you change this to Adam. Okay, so when you change this, when you run this, right? I want you to change this as well. Okay, may not be now, at a later stage, right? So whatever you specify over there will be the optimizers used. Okay, but right now we are using the batch. Okay, mini batch. Right. Whenever I say something like this and I overwrite that by writing this will be used. The batch size will be used. Okay.
Okay, sir. So this optimizer is different
Sorry.
than this. So
If
this term is different.
No,
This optimizer and the schemes, they are different or same term.
It's the same term.
Okay,
It becomes
got
same
it.
term under only one condition. If I use SGD and I don't use a batch, then it is the
It's
one which we are
SGD.
using. It's SGD.
Okay.
When I say that optimizer SGD and I use a batch size, it will use a batch
Then
size.
it's mini batch. Okay.
It said that, okay, it initially said that go for SGD, but now I'm supposed to use the batch.
Okay.
But in addition to that, you have other optimizers also available. What Keras has done that they brought everything into the same keyword, and in the optimizer you specify various things that will be implemented. Okay, so that's how it is.
Okay, sir.
All right. So anybody got the answers after changing the batch size to a different value, larger value? What is the is there any effect on the accuracy? That's my first question. Okay, so please try to implement, make a change and run that part of the code, and let me know if you have an answer. Okay, so maybe it will take some time, right? Because you see the data set is huge, like 60,000, and that will go into the machine several times, right? So that's why it might take some time. Okay, all right. So that's the one thing. Then anyway, meanwhile, when you run the code, I will tell you another change that I expect everybody to do that and see what is the effect. Okay, the effect of the dropout, that's very important, because If you enter a higher value, more number of weights will be left, right? More number of neurons will be left untrained for epochs. For every iteration, some number of neurons will be left, right? So initially, when I look at this concept, I see that how the training will happen efficiently in that case. Okay, but because of the number of iterations are too high, right? Right, even if you lose it, even if you don't train 20%, 30% of neurons, right? The research have shown that, right? This is still going to work. So that's what I want everybody to make sure that yes, this is going to work by changing this. But if you go for a bigger number, beyond 0.5, right, we will see that serious effect on our final results, right? The accuracy will come down drastically. Okay, but right, depends on your system. Slight variation is expected, 0.2 to 0.3, 0.4. We will observe some changes. Okay, slight variation will be there, but beyond a particular value, if we keep entering that, right, it's going to be reduced. All right, so that's the next thing, right? I want everyone to check. So if we don't have time now, please make a note. What are the changes that is required? And the next point after that, right? First, you remove this second set of convolution and the pooling, right? Just go with one set, convolution, then max pooling. I don't have line number 5 and line number 6 in this code. Followed by, I have the normal code starting from 7 onwards, right? So I'm removing a particular set of convolution and the max pooling layer, right? So when that happens, we are expecting something will change because machine is learning lesser number of features. There are less filters being used. So the number of filters used less means number of features you learn, feature maps you be obtain are also less. So because of that, right, we expect some changes. So we need to make note of that. All right. That's the point number 2. Then the point number 3 comes into picture. Add another layer. So copy this as it is. Line number 2, 3, 4, 5, 6 will be there. So after 6, repeat another set of layers. Okay. Add another layer of convolution 2D and max pooling. Right. Increase the number. 64 is there. Make it 128 according to convention, or give any number more than 64 or okay. We can repeat 64 will definitely work. Okay. And run the code and see the difference. Okay. Now what happens? We already have studied something. Simply keeping on increasing. If I keep on increasing the number of hidden layers, that is not going to work because there is always something called as a threshold. After that, if you keep increasing, what happens? Right? We have studied what is called as an overfitting. Right? There is a chance that you may observe the overfitting over there because of right more number of weights being trained and etc. Many things are there. We already have discussed about that. So because of that, there may be overfitting, which will show you reduction in the accuracy. So if that happens, you should understand that, okay, when I add a third layer, this is what is happening. If third layer improves your accuracy, that's well and good. I have not trained, but I'm suggesting you to do that. So once that is done, if third layer is improving your accuracy, add a fourth layer. Just I want you to see the effect of overfitting over. That's all. Okay, so just do that. So 3 things are there, right? Once this is completed and when you have time, please do that and make note of what is going to happen. So whatever we are going to learn from doing that, right, it will be helpful. It is very beneficiary when you go for the other things, maybe in your projects or something. It is going to help you. All right. So yes, we got one answer here for okay, changing the batch size, I guess, right? Nitin, it's 96.93.
Yes.
Right? Yes. Okay. So you can see that when I increase the batch size, right, the number of iterations reduce. Iterations reduce means, right, less number of times I'm updating my weights overall, right? So because of the number of weights getting updated lesser number of times compared to the previous case, there is a small variation in the accuracy. Okay, so we have another value from Amandeep. accuracy increased here, but batch size is 600, right? It will happen. As I told, it's different for different machines, right? So it may happen, right? So for the previous case, which I mentioned that, okay, this is what is happening, that's not happening here. So what could be the possible answer? Any guesses why the accuracy increased or decreased? What's the previous value you got, Amandeep? When it was 60, what was your accuracy? It was lesser? Okay, it was lesser earlier, now it is increased. What could be the possible reason? Let's think. I don't have a definite answer over here, but let's make a guess. What could be the possible case? Machine learned in a different way. The pattern in which the image is given into the machine is different compared to the previous case. Maybe that's one case, right? Possible. All right.
Yeah, so I just removed the second convolution and max pooling
Okay.
a layer, and with the 60 as a batch, I got a accuracy about 98.65,
Okay.
65, which is slightly 1% reduced as compared to
Compared to this.
when it was having.
Yes. Slightly lesser value. Maybe again, there are many parameters to be changed in a single case. Maybe you may have to, if you want to go with only one layer and you want to increase the accuracy, means you may have to change other parameters also. Okay, maybe that may bring it to 99. Once again, we have to check. Okay, but anyway, so the fundamental idea is that when you remove a layer, it's clear that, okay, we didn't learn that much like the previous case. Something, whatever the machine weights got updated, slightly lesser than the previous case. Okay. Yes. Anything else to be discussed here? Any doubts we have? Let's try to clarify those before we proceed. But the three things which I mentioned, please do that. Okay. So everybody, please take your own time and do that. That will be that's going to help you a lot, right? When you do something. Okay. Some real projects at a later stage. Okay. So if we don't have any doubts, I would like to proceed further. Right. So there was one question I think in the previous class, that is there any method so that we can identify the optimum value of the hyperparameter, not like the number of layers, like the number of neurons in each of the layer. It may be which particular activation function I'm supposed to use. Because anyway, theoretically, we have understood everything. So we have come to a conclusion that, okay, if this is the architecture that I'm going to use, right, that may be the best suitable or best way of generating the deep neural network using the convolutional layer, right, dropout, the pooling layers, etc. Already we have discussed that. Other than that, there may be still a question: what should be the learning rate, right? Some other parameters like that. So while answering that, I told that there is a concept in which we can write a code, and we have to use Keras. Others, we don't have such a support, such a good support in other tools. But if we use Keras, there is an option, and in that option, I am allowed to specify the range of any hyperparameter which I am intended to use. Like, I don't know which learning rate is going to work. Okay. But I may have a guess that, okay, I should start from 0.01 and I have to go till 0.1 and I will test. I want to do that. But if you want to do that manually, you will have to run the code so many times with each and every value of learning rate, so that, right, you will you'll be able to decide which is the best. Okay, but let's say I did that experiment, and finally I came to know that learning rate of 0.05 is the best one. So I fix the learning rate as 0.05 and I move ahead, and I will do something different. Maybe I want to check that for each of the layer whether the sigmoid is good or tan hyperbolic is good or ReLU is good. Anyway, right now theoretically we are very comfortable that okay, ReLU has to be used. But let us say for each of the layer I want to change the activation function and check, right? So you see that with various values, with the learning rate as a fixed value, you may have to repeat this, but there is a catch. So 0.05 learning rate may not be suitable when you use a specific activation function. You may have to change. You may have to go to a different one, right? So that is not possible now because I don't have any idea that, okay, if I use a learning rate like this with this activation function, my performance is not good, right? I have no idea, right? Only thing I can see that, okay, accuracy keeps on reducing, but I have no idea that, okay, the learning rate 0.5, which I fixed now, is affecting that. I don't know, right? Correct. So that's a problem, right? So there is a very good feature in Keras called as a tuner. You can tune, you decide your network architecture absolutely fine, right? But they have built up what is called as a tuner. That tuner is going to help you to decide a particular architecture, and in each architecture, maybe the first layer is a convolutional 2D layer. I have no idea how many neurons are present in. What is optimum one? I may write 32 initially. Later on, I may change it to 64. Then I'll change it to 120. Then I change it to. So every time you run, right? So it's going to take so much of time, right? So manual work is tedious, right? So in order to avoid that, the tuner helps you out in, right, giving a range, right? You have various hyper parameters. So we'll start step by step. One of them we'll see now, okay? Then we'll move to the what are the various options available, and at the end I will show you the complete code using which, right, you will be able to decide which is the best suitable one. That the machine itself will calculate. It will take time, so you should be ready for spending that much amount of time, because it cannot compress the time required to do all these calculations. Because I may say that I have 7 different hyper parameters. I want this tuner to suggest me what are the, like, first layered number of neurons, or even the number of layers also, right? That's also there, because I don't know, right, which is the best suitable one. I may use just 2 layers, I got some result. I use 3 layers, result may improve. I may use just 1 layer, result may decrease or may further increase, like just now we saw one example, right? So like that. So which is the best suitable hyper parameter, right? First we need to say that, okay, this is a hyper parameter I want you to tune, right? Varieties of options are there. I will discuss each and every one. This is right. When you have time, if you have enough time, right, and you want to go to a best suitable what you call architecture for your problem, then this is the case. Normally we don't suggest, but right, normally we don't suggest to use a tuner because it takes a lot of time. You're going to see that now when you run the code. Final code, when you run, it's going to take some time. But so there is an option. Yes, you have time. You want to go for the best suggestion that the Keras gives you, right? So that you can solve this problem with the best accuracy, right? This is the one option. Anyway, so I want you to get introduced you to this tuner part. That's why we are covering this up. So there is you need to import what is called as a Keras underscore tuner, right? I observed some of the installation of Keras. This comes by default. If it is not there, please install, right? You need to install. Okay, you can go for a pip install. Anything is fine. You have to install that. Okay, so just see whether it is there in your system or not. If it is not there, please install, right, the Keras underscore tuner. So once it is there, we'll import. Okay, that is a key. Right, now the first option is that when you use a tuner, it is suggested to build, right, a particular you define a function which creates a model. Okay, and then we keep calling this function whenever we need. Okay, so let's say that build model is the name given. HP stands for hyperparameters. some hyperparameters are passed means it will be. So normally you see this is still same. Whatever we are writing inside that is same. Model Keras dot sequential. Then model add a flatten layer. Right? Anyway, flatten can be used anywhere, right? So you know that whatever is my next layer size, according to that, it has to exist. That's all. So you see, now my intention is that I want to go for a dense layer, let us assume. But I don't know how many number of neurons are required. This is the fundamental step. We will go for other hyperparameters as well, but at a later stage. So let us assume that I have a data, right? I'm going to take the data. I'm going to give it to a first layer. Let us say that I am going to decide that I'm not going with a convolution or something. I'm going to build a very simple neural network, maybe under the deep neural category. I want to use a dense layer initially, but I don't know how many, what is the optimum number of neurons over there. So you just have to decide units equal to, right? It's an integer value. Whenever you say integer, it is int. So hp dot hyperparameter integer value. You say that units because how many neurons are there will be decided as units. Minimum value 32. I want to go with a maximum value 512. Okay, so these are the values I'm defining, and you have a facility to say that what is the step besides. You can see that increment in the steps of 32. You can go with the 10, you can go with 15, you can go with even one by one step increase, right? Whatever you say, it's going to do that, but you will also specify what is the activation function, right? So when this is done, right, whenever we actually fit the model, it will run everything for each and every value starting from 32, since I specified the step as 32, 32 plus 32, then 64 plus 32, like that. Every value it is going to run. Now you see code is going to run that many times. That's why I told you should be ready to spend that much amount of time. So there is no time compression that is happening. It will not do some magic to give you the answer directly. It will run for each and every value of the hyperparameter I specify, so that it's going to take that much amount of time. Okay, I hope that is clear. All right, so the others are pretty much same, right? Then I'm going to add a 10 class. You see that when I say that softmax function, you should understand that this will be the final value. So I'm asking the Keras to decide upon how many units are there in my first layer. Okay, input layer, so many things will be there. First layer, that's a hidden layer, decide the best values or the hyperparameter I want to decide is number of neurons, right? Then I decide that this data set has 10 classes, so 10 neurons in the output layer, so that you will get an output, right? And the next requirement is that you need to specify the compilation inside this function only. Okay. So because I call this function means it will be creating the model and it will also compiling the same, and I return the model. Okay, so this is just an introduction part, right? Just to show that, okay, what is going to happen. Anyway, you run this code, you will not see any output because we are not actually training or testing something, right? So this is the first part. Okay, now Keras actually supports you in another way. Just to tell that without running this with the actual data set, it will still help you out in understanding that whether this particular code you have written works or not, right? That is the next step. You call the function, okay, call the function, the same name, build model, whatever is there, you call the same function, okay? Then, right, Keras Tuner hyperparameters. This is the function, right, which says that if you get something like this, right, if you get a result like this, right, if you don't get an error, right, or any warning, that means yes, this whatever code you have written in the previous cell, right, that is going to work. All right, so that's just because when I say that I'm going to use this for an actual purpose, in order to come to know that there is an error or something, it is not training properly, etc., you may have to wait for a longer time. Just to avoid that, they have given this facility. Okay, right? It's something like, right, various building blocks of the previous cell, whether they are getting connected properly or not, they are going to check here, and they are going to give you this answer. Okay, so next layer. Oh, let's go one step ahead. Now, so here, as you can see, again, it's right. There is a sequential model, and I'll directly go for here. And this part we should be fine. Okay. In this case, you see, we are already whatever is there, we are using it same. But you see, activation, I'm not very sure. Let us assume. So now we know that Relu is good, but let us say I don't. What is the option? You need to use what is called as activation. It's not an integer value. If it is an integer value, you should use int. If you have anything else, something like a text, right, which you write here, you should use choice. Okay. What you want to choose, it's an activation function, right? From this, you can write any activation function here. Each and every activation function will be tested, right? It's going to run for that many folds, right? If you are running the code for 1000 times and I write 4 things here, 4000 times the code has to run. So just understand, right? So that many times it will run. So time required is going to increase n-fold, depending upon the n values we write. Okay, so I wanted to show you how do you do this. Then let's go proceed further. I have a doubt whether I want to use a dropout or I don't want to use a dropout. Okay, let's see that. So see the next option. I want to check whether to use dropout or not. So you will use hp dot boolean dropout, right? In the sense, whenever it says that hp means it understands that that is a hyperparameter. There is a hyperparameter to be decided, saying that yes or no type because it is boolean, right? Dropout, the dropout, yes or no. That's what I want this tool to suggest. I want that to be suggested by the machine, right? So you see that it will run the code with the dropout of 0.25. You can fix it. You can change this, right? Anyway, you can even change this value. Anyway, we'll come to that later, right? First thing, I want to know that whether I'm supposed to use a dropout or I don't want to use. I should not use a dropout. Theoretically, we have something we have studied. We will be seeing them, right? The use of dropout, yes, absolutely fine. But right, some combination of what you call number of neurons, a particular combination of what you call activation, dropout may not work. We don't know because we literally we don't have that much time to run for each and every case and see that. So, right. So for which one it is useful for, and at that case, what is the accuracy? Everything it will show in the form of a table. All right. We'll come to that when you run the code. Okay. But all right. So right. So this is how to decide that, right, whether to use or not. Right. Let's say I'm directly going for my last layer. Right. I'll use it. Now let's go for a learning rate. Right. So I just want to show you that what is the other option, that is a float here. So hp.float, it's LR. LR is the way how the machine understand that this is learning rate. Start from a minimum value and go to a maximum value. Okay. So which to what, right? So as I already mentioned in the when I gave an example initially, I want to start from this minimum value and I want to go to that value, right? So you can do that by specifying here. So now you see it's 1e minus 4, 0.0001 to 1e minus 2, that is 0.01. Okay, so that is the range which has been mentioned here. Any range you want, you can definitely try with, right? So increase this means it's going to run many more times. That's all. Okay, so just want to show you the range. That's why I have written a small range here. Okay, otherwise, yes, if you enter from 0.1 to 0.9, right, it's going to run for a longer time, and you will see that it will run, right, not like 0.1 to 0.23, no, it will run for, right, every real value that it can generate between them. Also, it's going to take a lot of time, right? Then anyway, I know that I have to compile the model inside the function itself. That's why we are using the this one. Okay, compiling here and return. So we'll return the model, and I'm checking that whether this particular code I have written in this block is going to work or not directly by calling the function I mentioned earlier. So you see that I'm going to get a proper answer. So that means it is going to work. All right. So, right. Again, this I was checking something. Okay. Don't worry. Nothing to do with the 15. All right. Next one, right? The cell number 16, right? There is another facility that it's something like there is an option that you define a model in some at some point. Okay. In some function, you define the neural network you want to build. Okay, so the network model is there somewhere in a flow. And then I may want to vary the parameters of that particular model which we have created, right, in a different part of the code. Is it possible, or I should follow the same thing I did so far? Right? So the answer is yes, you can do that. So this is another representation. That's not the only way of coding. You can do it in a different way. You have a very good help for this in the Keras documentation. Okay, online you can refer over there. Okay, so a part of this code also I have copied from there only. Okay, so this part of the code I am taking from the reference. All right, so let us say that I'm going to define a model in a particular block of the code in the function, say all existing code. In the sense, this is where the model is being built, right? So I pass the various parameters and I build the model. You see, right? I'm not changing anything. I'm not giving an option to the machine saying that, okay, change all these values from this to this. Tell me whether I should use a dropout or not. No, I'm not saying that. Okay. But I'm writing another function here. You see below that, it's a build model function. In the build model, I'll tell you what are the ranges. What the Keras has to tell me something, right? Right? It has to give me the options, right? So what are those options I'm specifying here? So units, right? The same thing which we wrote in the previous code, but here I'm writing it in a very different part of the code. This block of the code may be coming at a different location of your whole code, right? That's still going to work, right? Activation, same thing. We wrote there, it's separated. Dropout, HP dot this, right? Learning rate, etc. So now you see model is equal to call that particular. Now you call that with all these parameters because that requires units, activation, dropout, LR. So all of them you have right defined over here, and you are saying that this is an optional case. Like I want to use it or not, you have to tell. Right? You see dropout, boolean. Activation, what are out of those, which is best, you have to decide. So units starting from 32 go to 512 and tell me which is best to do. So you see, we are calling that particular function, right? Already built network with the option of what is called as a tuning. Okay, at the end you can check that once again by looking at the building, right? Call this and it will say yes, it can be built. There is no error. It will show something related to the memory or something, but don't worry, if there is no error shown, that means it is going to work. Okay, then I'll show you another option here. This is about the number of layers. Let's say that I don't know how many number of layers I require. So that's also pretty important, right? Normally, whenever we are confused which is the best suitable one, we have an option to use this. So this is the option. You just check here that build model, it's same. So sequential, flatten, everything fine. Now you see the number of layers is what I want to tune. How do you do that? Give a range. I in the range, it's integer of my hyperparameters. Number of layers is the keyword used by the Keras to understand that, okay, this is the layers. It's 1 to 4. 1 to 4 means it's a range, right? Python says that 4 is not included. So, right, 1, 2, 3. So out of the 3, it will start building the model with 1 layer. All other hyperparameters will be trained, right? It goes to 2. Everything else will be trained once again, right? Then 3, everything else trained. Then it will show the result. Okay, out of this is the best suitable number of layers, right? So in that, what you do for that, in that range, keep adding this model. Sorry, to the model, keep adding the dense layer. Again, you can use any layer you want, right? Go for a convolution 2D, anything. So as of now, I'm trying to stick to the dense layer itself because I just want to know that how do I add the layers? That's all. Okay. So in a layer, so when I is equal to 1, only one layer, I equal to 2, this model added twice. Okay, so this layer gets added twice, then thrice, and so on. Okay, so every layer also you will specify what is the minimum value, what is the maximum value, and what type of activation function it is supposed to use, right? Right, that also you are going to ask the machine only to fine tune, right? I think this part anyway we already have discussed about. That's whether to use a dropout or not, softmax, right? Sorry, whether to, what should be the learning rate, etc. We have. We are again asking the machine to find that out, and at the end you can see that right, we are compiling with a certain specification. So this is how we initialize the part of the code, saying that okay, this is my architecture and these are the various hyperparameters which I don't know what values are ideal or what values are the best suitable to solve a given problem, right? So I define and I ask machine to, okay, this is my overall architecture. I have some confusion in, okay, which value to use, how many layers, which activation function, etc. I'll just specify everything. That's done. All right, the next part is called as, right, I'm creating what is called as a tuner, right? There is a function to be used which is called as the random search, which is present under our Keras tuner, right? So I have to specify the following parameters when I call them. The hyperparameter is a keyword, is actually, right, a specification which I have to tell. You just tell the name of your function, right? So now what will be there? So this is the last function which we used in the code, right? So this is the one which we are referring to. Okay, it's actually asking for the number of layers. It is actually asking for the number of number of neurons in each of the layer, 32 to 512, which is the best suitable activation function for each of the layer, right? Plus whether I should use dropout or not. Now you see everything is there, right? So though we started with a simple case, now when we run the code, we are trying to optimize everything. Okay, we are trying to tune for each and everything over there. So then, right, everything is there, even the learning rate, whatever is required, we are asking. So that is the one which I'm referring here, right? When I pass, when I say that hyper model equal to the build model, it's the name of the function. Then objective, right, validation accuracy. I want to look for optimization of the accuracy. You can go with the validation loss, right? You have various options. You can go for loss, but normally we go for the accuracy. Okay, so that's the accuracy. Now each time, right, there is an option, right? So it will try 15 times, right? With one of them fixed, right? One of the value fixed, it will try to vary the other parameters 15 times. Otherwise it keeps on going, right? Because you have a restriction. There has to be a parameter to control the time, right? So that's the maximum trials and execution per trial. 15 times I want to do, right? Each time I want to try that only 5. Don't go beyond 5. Okay, so this is what I'm saying, right? Right. And then I say every time that if you get a best model, overwrite my previous best model. Okay, otherwise it saves it in a different location in your computer memory. Maybe the memory requirement is huge in that case, so you can use that parameter as well. There are many more parameters in the inside this random search function, but these are what I suggest. Okay, these you can vary and you can see what's happening, right? If you increase the maximum trials, executions per trial, it means more and more time, right? Initially I told that there will be a huge time, but they have given a particular facility here to control the time. But anyway, if I use smaller values here, all the parameters will not be tested, right? So when you give like maximum trial equal to say 4 or 5, all the parameters will never be trained. You see that I'm actually asking in the previous code, you see there are so many parameters. I'm asking the machines to say that, okay, give me the best for them. But if I'm not allowing the machine to run the code sufficiently large number of time, how can I expect machine to tune everything, right? Some of them will be tuned, others will be some random values is what it's going to come if you don't allow. So actually this 15,5 is not sufficient, but this itself is going to take a lot of time. All right. So I think you are running by now you are running this part of the code, I guess, right? If you are running, you'll observe that it's going to take some time. But you see, I'm showing the final results what I got. Okay, so it says, okay, sorry, that's not the final results. Sorry, my mistake. So once you do the tuner, right, it says that you can actually right ask the machine what are the things you are going to optimize. Okay, so that can be done using search space summary. What are the various spaces you are going to search for? What are the various ranges of variables? What are the various choices you have been given by the user so that you can choose? That's what is this case. Sorry, it's not the output. Okay, right. So using this particular command, you can see default search space has 5 different things according to this code, right? So the first one is the number of layers. It's an integer value, right? Minimum value 1, maximum value till 4, right? That's given in according to the range function. Then you can see the activation function. You can also see whether you need to use a dropout or not, right? What is the learning rate, etc. So various things are there, right? Which, okay, using this search space summary, we will be able to identify or we'll be able to see that, okay, what are the various parameters the machine is going to train. Okay, so any doubt so far?
So one small, can we just scroll little bit? See here when we are compiling it, we are not able like, okay, in this, we are not, only we are saying like, okay, optimizers learning rate, but can we like, okay, even change like, okay, optimizers in a search parameters?
Normally, the optimizers, etc., needs to be chosen by us. That's the
Okay.
way. How you want the machine to tune itself. Okay, it's not like the number of or it's not a parameter of the network. It's just a method, right? Just an algorithm, something like an algorithm.
Okay.
So since it's that way, so it cannot be included inside this tuning part. Okay, so which particular metric you want to use, right? Any metric you use, you will get a performance. That's all. You may look at the error or you may look at the accuracy. So it may not be suitable to ask the machine to say that, okay, give me this or that. Both it can be. Okay, so that's the way how Keras expects us to specify them in the compile part. Otherwise, this would have been added inside the model part. Right? So that's the reason why it is not included in the tuning. It's not a hyperparameter, basically.
Okay. So one question like, okay, on an optimizer. So how to like, okay, whether there is any guideline, okay, if this type of a problem is there, then like, okay, use this optimizer, or how we can really take a decision what type of a optimizer we should be using.
To answer that, we have something again. No fundamental rule book saying that, okay, this is what you should use for this. Okay, first option is that it's directly going to come. You can make a guess if you already have worked on some projects. Like I know image processing, I have done many projects, and then I may have some idea that, okay, the Adam may work better because it's related to the moment, because Adam is adaptive moment. Okay, so the momentum which we have used, right, it's working on. Okay, otherwise the gradient descent is most commonly used, right? So SGDM, stochastic, that will also work, etc. But most of the time we will be able to change the optimizers only if you have some issues with the current optimizer. There is no fundamental rule saying that for this problem you have to use this. Okay, so that's the first thing. Normally we start with either Adam or the SGDM. Okay, so gradient descent, those are the common ones that will be able to solve any problem. It's again 99% of the time. Only when you see that, okay, my SGD is not at all tuning, it's always giving 50%, then only we shift to the others. Okay, otherwise, both are, they just have changed their equation in slightly different fashion, that's all. Other than that, there is no much huge difference when it comes to the optimizer. Okay.
Okay. Yeah. Thank you.
Okay. All right. Any other doubt? Okay, so what we do, please run your next part of the code, because towards the end we have the training part, which is going to take a lot of time. So please run the whole code from yourself, and we'll take a break. Now it is 1:35, so we'll join back at 1:50 and we'll continue. Meanwhile, keep your code running. Okay, all right. Okay, so we'll meet after the lunch break. So far we were running a part of the code where we suggested that, okay, these are the various parameters so that we want to fine tune, right? So it suggested by using this particular function, search space summary, right? It is going to show you, right, what are the various parameters and what are the various values it's going to sweep through. Okay, now, so we built the model, we'll get the data set. Okay, so this is a pretty much similar code which we have used so far. It's the fashion MNIST data. Again, this is a data set that contains 60,000 training and 10,000 testing data on various fashion images, right? Like shoes, ties, watches, right? Pant, shirt, etc. Skirts, many things are there, right? So we'll simply convert them into the floating data. That's the first thing here, and dividing by 255 just to bring the range from 0 to 1. Again, this is just an optional case, right? We can still keep the everything in the same format and we can still process. Okay, so 255 dividing by that is another form of normalizing, right? So the range will be converted from 0 to 1. And okay, so this is just a pre-processing. Previously, we did it in several steps. We are doing all of them at once. Only difference is that the normalization is dividing by 2. So another way. Okay, now the tuner begins in the following way. So you have to say that tuner dot search is the function, right? I just have to specify x train, y train, number of epochs. It's like, right, everything we did for a fit function. Whenever we used to fit the model, right, we used to call this particular function. Okay, so tuner dot search, x train, y train, number of epochs, validation data set. If you have anything, you call. So now you see here we have created a validation data set as well. Okay, x val and y val have been, right, separated from the actual data set, right? So, right, I have used the validation data equal to x val comma y val. Again, this is optional case, as I already mentioned, right? You can directly go for testing also if required, right? So after that, I am actually asking for the best model. This creates the several models of it. Will arrange it in the format. If at all you have not written the, what you call as the overwrite is not used, means it will save everything, but in the decreasing order of that particular validation accuracy. So if I am asking for objective is validation accuracy, in the decreasing order it will keep, right? So you can simply, right, use a indexing 0 to access the first, right? So tuner dot get best models, it will show you the all models if you simply try to, if you try to visualize that. But now you see this is what 0 is the first one, so that's the best model. So anyway, so I didn't use it initially. I just tried to do something here, but anyway, so as of now in this particular cell, this has nothing to do, right? This is the first one. As soon as you run this first line, it's going to take some time. Maybe if it is running on your side, you may observe that you are in a certain number of epoch or trial number 5, 6, 7, something it will be showing. Okay, just observe that, and there you will see that so far whatever is the best model, best parameters you obtain, everything will be shown in the form of a a table. Okay, again, I am not able to show you that right now because I already have run that code. You see that it actually ran for 1 hour 19 minutes on my system. Okay, once it is ended, you will be seeing that the best value, whatever we asked for the optimization, this is what I asked. Okay, I want the best value for this. Tune the whole set of parameters and get me the best model, which, right, is going to get the best value of the particular parameter. Like here, we are looking for the validation accuracy. So that validation accuracy is 0.89, 89% is what. Okay. So again, as I already mentioned, the number of times, right, the trials I mentioned as 15 is basically not sufficient to go to the optimum values of 90%, 95, or even 99. If you want to go there, right, we have to give more time for the machine to get tuned. So I gave something like intermediate value. 15 is not sufficient, right? Again, now there may be a question: what is the value I'm supposed to keep, right? So again, so in this case, anything around 100 should work, but that's going to take huge amount of time. It will run for days. Okay, maybe at least 1 or 2 days it might run. That's what is my expectation. Okay, so yeah, any doubt so far in this particular part of the code? Please let me know. Otherwise, let's ask someone to share the screen so that we can see what is happening. Okay, so how the train, because everybody may not be running, I guess, code by themselves. So, right, please volunteer someone who is actually running the code and we can see the tabulation which is being displayed. Anybody who is able to show that, kindly. I want you to share your screen. Right? Anybody?
Yeah, I can share.
Yeah, kindly share. I'll stop sharing from my side. Okay. Yeah.
I need a permission.
I think I have provided the permission just now. Kindly check now. Is it possible?
Yeah, can you see?
It's yet to come. Yeah. Now. Yes. Can see. You can see. Can you move down or up so that we can see the?
So basically now this is where like tuner summary,
Okay.
search space summary, and below that this is what I have got after the yeah.
Okay. 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 So
Which is
oh, okay. The training is over, right? In this case.
yeah.
Yeah. Okay. Anybody who is still in the training phase and the training is not over, I want to visualize the tabular format which comes in this particular cell number 26 when the training is still going on. Anybody?
Actually, it just finished when I
Finished.
said
Okay.
yeah.
All right. No. I understand. Okay, that's fine. Because we have no idea when it's going to finish, right? Okay, that's fine. So it ran for 1 hour 49 minutes and the accuracy you are getting is 88%, right? That's very close to the range in which I got that. All right, so that's good. All right, so others, are you getting any? Are you still running? Anybody? Still running means I want you to show the screen, please, because if we run once again, I may not be able to show the next part. That's why.
Yes,
Should
sir.
I stop share? I'll stop sharing.
Yes. Yes. I think Jyoti can share.
Yes, sir. It's running, but I don't know how to. I mean, share the screen in Zoom. I don't know.
Okay.
Is it shared screen?
Yeah, you have an option
Okay.
called
Yeah.
share
Yeah.
screen,
Okay.
and just select the appropriate window which shows the
Okay.
Jupyter notebook. Okay, and that will get shared automatically. Okay, I think
Is it shared, sir?
yeah, I think we can see.
Okay.
Can
This
see your
this
screen.
box are running.
Go to that part where the running actually is happening.
Yes.
Okay. Slightly below, maybe.
1 second. This one.
Yeah. I think that one.
Okay.
No, where is it?
Okay.
Oh, where is that? We don't see
Yes,
the
sir. Here.
yeah,
So
that
this
part.
is yes.
Can we slightly you go above so that we can see a table that is being created. Okay, it's not showing the table. No, only
Table. Okay.
there is a table that is actually getting created, but it's actually slightly above. You may have to go
Okay.
up slightly.
Okay.
Click, not there, not there. Click on that internal
This
box,
one?
what you see.
Okay.
Inside box, you
Yes, yes.
click on
This
that.
is the
Yeah.
table. Third
Yes, yes,
fourth
yes.
trial is
Perfect.
running. Yes, yes.
Now you can see that it updates every time it's updating. You can see the values so far. The leftmost column says that value, in the sense that is the value for which the hyperparameters are being tested for. Value equal to 3. What is that? That is number of layers. Rightmost side you see the row wise, if you read, it reaches the num layers, which means number of layers is 3. Right now it is running for value equal to 3. But second column says best value obtained so far is 1. For whenever the number of layers is kept as 1, right, it says that the best results that has been obtained. Similarly, what are the other values, right? So you can see unit 0, units 0 in the sense how many number of neurons are there inside that layer. So 320 gave the best results, but right now it is testing for 480, right? So activation, best value is ReLU, right? But right now testing for tan H, like that. Dropout, false give without using dropout, it got a best result so far. Right now also it is continuing with the false. Okay, next row says learning rate LR. You see the value is 0.00036 is the best value, but right now it is testing for 0.02554, like that. So units 1, unit 2, they are required because right now the value of the number of layers is 3, correct? So 3 layers means 2 more layers have to be added, and what are the values over there? So far best value is not there because it never tried with 3. This is the time it is testing with the 3. So best value is none. Right now it is testing layer, next layer, that is second layer, unit 1, 288 neurons, and unit 2 it is 198 neurons. So you see, as the time progresses, this value gets updated every time, right? It runs with the new test. This changes. Now you see, running a trial number 4. So far, it is running right since 28 minutes. Right? It will take a lot of time, right? Like 1.5 hour or something close to that. Right. So to finish the 15 trials which we asked for. Okay. Again, I kept it moderate. It's not sufficient. Later on, when you have time, and if you have time, you please enter number as 100 and run that. Okay. So that will take you to the ultimate optimum values through this. So the idea here that we need to understand is that there is a facility like a tuner, right? And this is the way how you are supposed to write the code. And when you run the code, these are the options that we can see. Okay, so fourth one is over. Now you see it is the fifth one, right? So trial 4 is over, right? And accuracy of that is very less, right? It's 0.10. It's actually less, but so far, right? Overall 4 trials, the best value is 0.8887, running for 45 minutes. And now you see it's something is updated, right? So all the values are updated, and still it keeps on updating as it progresses. Okay, so I hope that is clear. And thank you, Jyoti, for sharing the screen. Thank you, Nitin, as well, for sharing the screen initially. Okay, so
Okay, sir, how to just stop share? Okay.
please, you can stop sharing. There itself you have an
Okay.
option.
Okay.
Okay, all right.
Okay.
Fine. All right, I'll share the screen again. Right. So let's proceed further. What are the next things that are going to come now under this case is, okay, let me, okay. So let's say the tuner has trained something, and it has performed its job. Now it actually saves it in the decreasing order of whichever parameter, right, we asked for the fine tuning. Like I ultimately look for validation accuracy. That's what I have mentioned in my code. So it assigns, right, every time it had calculated something, it puts up in the say in the form of an array, let us say. Okay, so in that the first one is the best one, but you can definitely see best 2 models, best 3, best 5 models, etc. So here it's a code for best 2 models, right? Models equal to, right, get best models of models equal to 2, right? That will come in the model, right? Out of which the first one that is indexed by 0 will be the best one. Okay, so you can see there, right? Now you see the model is there, right? We have to create a model, right? So that happens with the best model. That's the name of the model we have given to the best model. Models of 0 is my best model. You build the model with the input shape. And we see so far we have never mentioned, right? So input shape was given for a convolutional layer, but I'm saying that the input layer which is going to come there, that's all this size. Okay, so I go for a summary, and when you click the summary at the end, you will be able to see the created model, right, and the various parameters related to that. So here the last column parameter says that how many number of weights are there to be trained for this. So below that you can see total parameters, right, 735, 562. Okay, and also, right, that's one option. That's how the model is something like initialized with the input values that are going to come. Right. Other than that, you can have another option to see the results in the form of a summary by using tuner.results underscore summary. Right. So it's going to show you, right? I think every value it has trained. Just see that. Okay. Sorry. Okay. So now just see. So then what values are there? It's the top 10, I guess. Not, it will not show everything. I think that only the top 10 will be shown. Right? You see here, yeah, showing the 10 best trials. So I didn't see that. So showing the best 10 models are being shown with the parameters. So one of the training had number of layers equal to 3. Units is 512, ReLU function, no dropout, learning rate equal to this much, and all the 3 models having these values. 320 neurons in the first layer, 512 in the second, 512 in the third, right? That actually scored a value of 0.89, right? So this is the value which we can see. Then you see the next one, right? With the, right, 3 layers, first layer having 384, sigmoid function without dropout. This gave you 88, and so on. You will be able to see that, right? Everything it actually had changed, right? With the various values of the hyperparameters which we mentioned. It can be learning rate, it can be the activation function, it can be also, right, the number of layers, number of neurons in each layer, etc. Everything it will change. So that change is very clear here, right? You can see that, right? So with these values, it actually attained 88%, right? And so on. So various values that you can see, right? The best 10 only it is shown having service. The summary shows the best 10. Okay, now, so out of those, right, you can pick up the hyperparameters, right? Whatever parameters it has been chosen, you can select them. And so best HPS is the tuner best hyperparameters of, because we asked for 5, I'm asking for 5. Sorry, there is a mistake, not top 2 hyperparameters, it's all the 5. My mistake, there is an error. Okay, so build the model, right? Right, it's a build model. It's the same function which we had used earlier, right? So that one, and you, right, fit with the entire data set so far, right? Again, this is optional case, right? It's not a it's just a convention. When we select a particular tuned parameters or the network with the tuned parameter, it is better to try with the complete data set, right? Because we have splitted that, out of which only one portion has gone inside. Maybe there was a training, validation, testing, etc. Now, right, convention says that, right, you can try with everything, and just to make sure that yes, this is the best model. When I train with the complete data set, still I get the same range, whatever I got earlier. It's just to make sure that yes, okay. So the model which we built or the model which we suggested is good, right? You can ensure that with the training with the complete data set. That's a part of a convention. That's all. right? If you are still using the same training part, don't train here. Don't do the fitting. Okay, it's not necessary. Right, so you can see here it actually provided me a much better value, which is 92. I think earlier it was 89 point something close to that. But after training this, right, with the complete data set, you can see that, right, we get a much better value, which justifies that, okay, whatever it could train, yes, it is valid, and it's still true for right, it's still it is true for the other data set as well, other part of the data set as well. Okay, so that's all about the tuner that is available inside the Keras. All right, so it's very useful, but it's a time consuming concept. But yes, right, when I want to achieve a certain accuracy and I don't know this particular, I don't have any idea about the various hyperparameters, we can use it. Okay, it comes handy many times. Okay, so any doubt so far with whatever we have discussed? If there is any doubt, please, we are open for oral questions. Please ask. Okay, so meanwhile, I will share a particular link. Okay, everybody please open that. All right, so that's our next topic. Even I'll open that. Right, but before that, if there is any question, I'd like to answer that, and then I want to go to the next. Okay, so I hope the concept which we were discussing is clear, right? Right, and I want you to play with it, right? Vary the parameters, right? Change everything that you can, right? Alter and right, work along with that, and take any other data set and see whether the parameters we tune for the current data set is useful over there. Normally, it will not be useful. Okay, you may have to tune it again, but right, yes, you can try that out. Okay. All right, so let's move to the next topic that is actually called as the TensorFlow Playground, right? So the name given is a TensorFlow Playground itself, and it is, again, it's a part of the TensorFlow, and it is completely supported by Google. Okay, so this is a very intuitive way of visualizing the problem, the data points, and the network that we are going to use, right? And how the machine is classifying, right? So on the leftmost side, you can see that it's a data. Okay, so data is there. That's the leftmost. Then what type of classification you want to perform? The data may be scattered in different formats, right? It actually varies on what exactly I'm looking for. If it's speech recognition, or is it like 2 or 3 dimensional data points which I want to classify, etc. Anything. It depends on that. You can see here, you can select which type of data that you want to use. Values are not available. I don't have to create the data. I can simply say that, okay, my data set looks like this when I plot. So you have an option, right? So there are 4 fundamental ways in which the data sets are normally scattered when you plot. Okay, so that's what is there on this side. Now you see you have an option for rate of training, testing, etc. That's there. If you want to add noise to the data, yes, you can. So noise suggests that whether there is any mix-up between the classes, right? If there is an overlap, how much overlap it is. Serious overlap means you have to increase the noise to a bigger level, etc. That you can. Okay, then you can decide what is the batch size. So normally these are the parameters, right, which the user has to decide, right, whenever you build a model. Okay, so on the top you can see that which is the activation function, sorry, the learning rate. First one, you click on that, you will see the learning rate. Okay, next you can choose the activation function. We have ReLU, TANH, sigmoid, right, and the linear functions available over there. You are free to choose. Then the regularization, yes, we know that L1, L2 regularization, right? In addition to the J, that's a cost function, you can add the weights or the squared weights. If you simply add the magnitude of weight, that is L1. Squared weights, it means it is L2, regularization, right? So regularization rate is also possible. There is a lambda with that regularization term. So that lambda, how much you want to use, it's asking that. Okay, and what is the major problem that you are trying to look for? Is it a classification or is it a regression? Okay, so let me recall what is a classification, what is a regression. So classification is a straightforward problem. Whatever we were solving so far is a classification. I have many classes and I give a test data. Learned machine should be able to tell that, okay, your test data belongs to this class. Similarly, there is another kind of problem that we normally face is to make a guess of my next value. That is called as the that actually is the other case, that is the regression. All right, so regression basically does the guessing. It will fit a curve, right? Like for example, let's say I want to guess what is going to happen with the Indian stock market specific stock price when it opens on Monday. So now still it is Saturday, I want to guess. So you see, you can build a model that actually, right, takes care of all the values, all the previous values, maybe last 100 days. I have to feed the values. Machine will fit a particular curve for that and it will predict what is going to happen next. What will be the next value? Okay, so that is a regression kind of problem. So you see, right, every parameter that I want related to a particular data set, I can choose from the left side column or the row on the top. That's the first thing. Okay, and right, you can decide, right, what type of features. Again, you see, no equations, nothing, right? You cannot ask that, how do I go select this particular feature? That option is not given here. But if at all you choose something like this, you see, the X1 says that two classes you are going to, let us say the feature separates vertically, something like that. Second row says, the second X2 says that you are trying to separate horizontal. So horizontal separation, in a sense, you are trying to draw a straight line, right? Like this. You are trying to draw a straight line like this, etc. Right? So that's what was when we discussed about the features, right? Initially, the weights are used for drawing the straight lines, etc. We discussed, right? So it's something related to that. You can call them as the features. What type of features of the data set is going to come to this machine is the question. So now you see, this is not a convolutional neural network. This is a simple neural network where the feature needs to be extracted before the training happens. So you see, right, this is a neural network part. But this is very intuitive. We get a lot of information, right? That's why I'm taking some time so that you later on you play with it, you understand. You take a lot of time to do a lot of experiments over here so that you can get some insights how the output is actually getting classified. As of now, you see, it is not getting classified, right? So right, we want the classes to be seen on the output so that, right, the blue colored dot should be bounded by the blue region. The orange colored dot should be bounded by only the orange region. So if at all it happens when we run there is a run option also, you can see here, right? I have a run option, but as of now, I'm not going to touch that. We'll discuss about the various other options here, then we'll start with it. Okay. So that's the first thing. What type of features you want to, right, use? You can use anything you want, absolutely fine. Then look at the number of hidden layers. You see, you press, when you increase, it increases the number of hidden layers. Each of the layer, right, you have an option. In each of the layer, you can use a plus, minus. You will be able to see, right, what's going to happen when I run the code. So maybe keep increasing this or reducing this. Okay, so maybe let me say, I don't know which one to, you can start with any point. At any point you can start. Okay, so output is there, right? So maybe let's increase one here and then let's come to the next layer. Okay, so let's say this is what we want. And okay, let's see, you get to start with this is sufficient. So simply go and click on this. Okay, so you on the top, you can see that the epoch keeps on increasing. In the sense, so many times the data is being fed into the machine. On the right hand side, you can see that there is a loss curve. Loss initially it was high, now it is being reduced, right? So that's one very important thing that you need to see. Now, how the signal flows, right? Also, you can see. Okay, so anyway, we are not going to look at the equation wise, but what exactly is happening there? They have given a hint. This is the output from one neuron, right? However to see it on larger, that's all. Okay, so you can click on that, you can see on the output, this is what is happening. From this neuron, it is able to separate, it's going to create a straight line such a way that you are trying to separate the bottom right orange colored dots. So go ahead and click this. It is trying to create another straight line, separating another class. You see, right? When you use 4 neurons, this is what is happening. Go to the next case. So from whatever it has learned from the previous layer, you should do something more. Right? So you see here, this is what is happening with these neurons. Then go further, one step ahead. You see, this is how the classification happens. And ultimately, as of now, after 2000 and odd iterations, this is what is the classification. All right, so this is how the machine has learned. Again, we don't get any update about what are the weights, how, etc. That's not a clue. This is the idea behind building what is called as this particular what do you call the playground. It's called as a playground, tensor board playground. The motto behind this is just to make sure that people can visualize what is happening. You will never get any idea about what is the weight, what are the weights, etc. You don't get any details about that. But visualization is important. Now, this problem might look very simple. Change your data set to other possible values. Okay, other values, other patterns you choose, and try to classify with the same thing. You will see that it's not classifying. Maybe if you go for a very complex data such as this one or something, let's try to start with this. It may not be able to learn, okay, because the data set is complex, right? So left to you, right? Design the network, right, and visualize how machine is able to go forward. Okay, so that's the ultimate idea, right? So I wanted you to get introduced to the what is called as the playground, which is a part of the tensor flow and completely maintained by the Google. Okay, so any doubt about this? It's simple tool, right? Please work on this just and visualize, right? What are the various options available and how what are the number of hidden layers required, etc. We can modify and we can visualize. Okay, that's the fundamental idea. So now you can see after 1600 or this thing, still it is not able to clearly separate them. So that means number of hidden layers are not sufficient, number of neurons defined are not sufficient. Also, you may have to change, right, the learning rate, right? You may have to change the number of neurons, hidden layers, etc. Okay, so modify that and please use this. Okay, so any doubt, anything you want to discuss about the playground? No, right? Okay. All right. So let's move further. Okay. We'll move on to the next topic. I'm going to share another one. Okay. Okay. This is a collab file. please download and open it in your individual lab sessions. And let me try to connect to GPU. It says it is connected. Let's see. Yeah, so a GPU is connected in this case. Okay, try to connect to GPU. Right, so we will move on to the next topic, that is called as the computer vision. So computer vision basically deals with the processing of the images and videos we obtain at various for various applications, such as maybe the medical field, self-driving vehicles, right, the camera, right, maybe the filters, etc. Wherein the application of image processing is going to lead us to a topic that is called as a computer vision, where the machine is assumed to have a vision and machine is made to take decisions, right, based upon whatever it actually captures through the camera. Okay, normally there will be a camera which captures the image. Image processing will be taken place in a onboard computer if it is an embedded system, and then right some decisions will be taken by the machine. Okay, so anyway, I have written some introduction part over here. Right? Instead of writing it on a separate slide, I just have pasted here. Okay, so when you read it, I think you will understand. I quickly go further. Okay, so let's try to finish this. Whenever the computer vision related projects comes into your hand, normally, right, you will not be having a huge data set with you, because what you are trying to implement is something very practical. Let us see, right? For the time being, let me say that I simply want to build a system, maybe an embedded system, maybe using some hardware, right? Maybe a Raspberry Pi or even the Arduino will work for us. I will interface a camera to that, right? And from there I capture image comes to my computer. Let us see. Okay, even if I say, no, why you want to go for a hardware, let's use the camera that is over here, right? That's also fine, no problem, right? So somewhere we collect the data, and that data is stored in a computer, and at a later stage I may want to give a new data for a classification. I would like to still stick to the simplest problem, that is classification of cat and dog. Let us see. Right, I may not have sufficiently large number of data when I start working on this. So what is the option, how you can obtain a larger number of data, or whatever you have, how can you convert that into a larger number of data? That's the first thing. Because previously when we were using the simple neural networks, we had the problem. What is the problem? The problem is like yeah, so you need to have the image, that particular object which you want to detect. It's actually a part of even the object detection. I want to detect a whole object, whether it is present in the given image or not. Let's see. Even in that case, right, when we were discussing about the basic neural network, we have understood that there is a problem. That is, you need to train the machine such a way that the object is located at every point on your image, plus it has to be located at various shapes. Like if you train it like this, if you give it in this way, it will not detect the normal neural network. That's a problem. So to overcome, we design the filters and apply the filters, perform convolution, absolutely fine. Okay, but even in that case, right, when you train the machine, it is better to have, right, uh, the object which I want to detect positioned in every possible way, in every possible scale. Small dog, big dog, right, thick, thin, right, very small one, etc. I want to create that, but it normally it is impossible to get all such data set for training itself. So from whatever I have, I will try to generate them. So there are fundamentally two different techniques that we are going to use when it comes to the image processing, or the under the computer vision. Whatever we do, we will be using two techniques. Okay, so this is used for enhancing the data set. So first technique is called as image segmentation. No, sorry, not segmentation, augmentation. My mistake. Segmentation is cutting the image into several pieces. That's not. Okay. So the segmentation is not going to be done. We are going to do what is called say augmentation. Right. So whatever I just mentioned here, we have written that over here. Right. So the augmentation generates very similar images that you already have, but in different ways you try to use the same data to create something. Okay, so maybe you will try to perform what is called as you may zoom in, zoom out, you may flip, right? So if I have a dog sitting like this, I'll flip, right? I can vertically flip, etc. Many things like that we can do, right? So the augmentation is one of the very useful very useful step in computer vision. And yeah, so this last line you see, image augmentation was it's a reason behind the success of AlexNet in 2012, right? So that time for the first time they brought the concept of say the AlexNet. Okay, so let's do one thing, right? Let's see the first part of that. We'll try to look at the augmentation part. Okay, so the augmentation, let me pen. All right, so we import the various tools required. Right, any tool you are missing on your system means kindly install that. Okay, so it's again this is you are running it on the Colab. Even the Colab hardware which is allocated to us may not have the required tool. Simply go for pip install, right, individually. If you don't have a torch is there normally, torch vision is also there. If you don't have the D2L, kindly install. Okay, pip install, do that. It will install. Okay, it will take just 1 or 2 minutes of time. Now, so in that I'm simply calling an image. So this image is actually there in my system. So you can simply call it. It will print any image you have. You call it. Okay, so copy and paste that image to the particular location, or let me do one thing. I'll share you this itself so that everybody has the same. Okay, just 1 second. Okay, it's yeah, I have shared it in the chat. Please, you can download if you want, and right, you'll be you please paste that in the same folder where you are. Okay, it's not, you don't have to paste it. Sorry, I'm mistaken. So, I was thinking that we are running it on Jupyter. So the procedure is like this. So click here, not here. Sorry, click here. This one. So right, just go for files. Okay, select, and a window will pop up, and from that window you need to you need to mark the point where you have downloaded that particular figure and click on that. That will come here. Okay, so as of now it's not even present in my system, so even I cannot run now. That's because whatever I have connected now, it's a new runtime compared to the one which I ran earlier. Okay, so I'll also do that. So let me click on this. So I'll just click on cat. It will say that once it uploads, if your time is gone, you will lose it. So you see, that's what had happened to me, right? Previously, I actually had this here, but so since the runtime was lost, even I lost the images. Okay, so then you can close this. Okay, so use this, right? So this particular files you click and then go for this upload option. Click on that, right? Browse to the file which you have downloaded or any other image which you have in your computer. Click on that, that will come. Okay, from then only you can run. Okay, everybody with me? Okay, so this actually this part of the code, this cell, when you run, you will see this the image of the photo of a cat lying down. All right. Now the first method of augmentation, right, is right. then you will bring a randomness into picture. You don't specify that, okay, I want only this particular technique needs to be applied whenever I go for the, what you call, whenever you use that, you have to specify that what is the amount of randomness you want to bring it into picture. Okay, so right, again we have written a code here, right? That code automatically, right, does the job. You see here, right, it's a apply, so image, and we are reading the various parameters over here, and this is augmented image for, right, I'm specifying the range for every pixel, right, in the range, number of rows into number of columns, right? D2L image show, right, I'm showing that image, y comma number of rows, number of columns, and the scale is the one which is decided, right, which will decide that what is the percentage of augmentation that is happening, what various types of augmentation we are going to have. So this is just an apply function. You see, number of rows and number of columns will this is going to tell you my final output that I'm going to see will have 2 rows and 4 columns, totally 8 different images I'm going to get. So I am defining an initial scale of 1.5. So if you increase the scale, your images get bigger and bigger. If you reduce that scale, images get smaller and smaller. Okay, so when you run, you can vary that and see, right? I'm just defining a function, but now I'm starting with the actual augmentation concept. So the first technique under the augmentation is a flipping and cropping, right? So flipping, basically, right, you can flip horizontally, flip vertically, 2 options you have, right? So the first, I'll not explain with the theory I have written here, right? I will quickly go through the next part. So there is a random horizontal flip, right? That is used for flipping your images horizontal. Okay, so you can see that the original image is like this, the head of the cat towards the left, but you see it's randomly flipped. Some of them will be on the right side, some of them will be on the left side. Okay, so that's what is the random horizontal flip. Similarly, you have the random vertical flip. Flip it vertically. Some of the images you may not see any effect whenever it gets flipped. If it is really symmetric, right and left side of the image very symmetric, and I flip it, I may not see any difference. It may be horizontal or vertical. But you see here, in this case, we have some effect. You see this part, it is bright. It is vertically flipped to get this part bright. Okay, so you see, right, there is a change. This region and this region, there is change. Okay, like that. So that is what is called as a randomly you are flipping horizontal and vertical. Decide any number of images you want. Okay, so that's one thing. And then you see the second option is that random cropping, right? I may have an image, but you may zoom in, zoom out, or you may move the image to a different location because we want to cover we want to create the data set in such a way that, right, the object which we want to detect should be present anywhere possible, right? So that's the reason. You see, original image, compare, this is object is at the center. Normally when I click a photograph, I might take care that yes, this is located at the center, right? But whenever you want to detect whatever you captured in a real time, it's not always true that you will be able to capture. You place the camera in front of, maybe in front of your vehicle. Let us say I want to detect pedestrians. If a pedestrian comes, you need to brake, right? So in that case, you may not expect that always the pedestrian is at the center of this. He may be located at a corner of an image on left side or something. So you see, it is necessary. Also, the pedestrian's characteristic may be different: small, right, tall, right, thin, thick, etc. Many options are there. So this is absolutely necessary. Cropping is also necessary. Though I have one picture, I can convert that into 1,000 various options by placing them at different location, different size, right? Comes under the concept of cropping. So you see here, this is again random cropping. So there is a function, right, present inside the torch vision. On the transforms module, it's actually random sized crop. So you will specify, right, the scale and the ratio, right? So you see, right, 10 to 100% is what I want. That's what I have written, scale 0.1 to 1, 10% to 100%, right, of the original image, and the ratio of width and the height I want to change is 0.5 to 2. So that's what is the ratio. Okay, so 200 cross 200 is the size of the picture which you get as a result. Okay, so that's what is there, right? And then the next option is, right, so right now we are going to look at what is called as the under the computer vision. You can still apply whatever we discussed so far in case of a neural network or any other standard network, VGGNet, right, or inception or any other, right, whatever we had discussed you can apply. But now as a fundamental part of computer vision, I capture the image. What do I do? I don't have enough number of images. How do I start with that? That's our idea. That's our motto now. Once you have created a data set, you can use any method we have discussed so far, right? Start from a very simple neural network. You can start. You can go to the next level, go to the deep learning concept, increase the number of hidden layers, change the activation functions, and bring the convolution neural network part, right? Dense layers, right? Dropout, many things you can do, right? So the concept still remains same. That's why we learned the new convolutional neural network and the basics of neural network at an initial phase. Now we are coming to something called as the application part, wherein in order to build some application, you may have a little amount of data set with you. How do you make sure that your data set is complete, right? That's what is we are looking for. Okay, so the next one is changing the color, right? So changing color can happen two ways. You keep the color space constant, change the brightness. Maybe that's one of the options, right? Because whenever you go for a testing, right? Maybe during the training, whenever you capture the image, there was no rain. Okay, my objective is to detect a drone from a video clip, let us say. When I trained my machine, there was no rain. Okay, it was bright. But when I go for actual testing, it's a something like the forecast says that it's going to be raining. So you don't have that much brightness. So whenever you train, if you try to make sure that you have all the ranges of brightness possible, then it becomes easier for the machine, right? So that's this idea behind this. So you call what is called as a color jitter. So these are the various things you can actually alter, but I showed only with the brightness one. Okay, so you can see the result here. So when you see my screen, even if it is not clear, please run on your side so that you will be able to visualize clearly the difference between each of the images. Okay, so this is first case, and even you can change the hue to get various colors again, right? It's optional. When it comes to say the cat, this may look funny because colors may not be possible. All these colors may not be possible for a cat, but yes, if you are going for an object detection, definitely this is going to be very helpful because object may be present in any of the colors. You may train the machine. If you create enough data set with all the possible colors in place, yes, that's also going to be very helpful. Okay, then we have another part that is called as inside the color jitter. You change each and everything, right? Add some values to that so that you can see everything, and the color as well as the brightness is going to change, right? So this is also very useful. You can create something like this. Okay, so coming to the augmentation part, which we have been discussing so far, we can see that, right, many options were there, right? First one was simply flipping, second one was something like cropping, various types of cropping, then maybe only changing the brightness, maybe changing the hue, color, and mixing up things like this. What if I want to do all of them, right, at once? Because now we were discussing it piece by piece. So now combine, right? How do you combine? Now you see, right? So there is what is called as a compose, right? Inside that you specify, right, dot vision transforms, random horizontal flip is what I want, color augmentation, this is already defined. Previously we have defined how the color should change. Shape is already defined in the previous cells, right? So I'm saying that use all of them. Compose, right, is my function. So if you use that, right, you will get a set of images like this. So you see color is changing, the randomly it is actually flipping as well. Some of them flip to left, right. I think it's only horizontal flip, sorry, only horizontal, not vertical. Okay, and you can see the color changing, the hue, brightness, etc. Everything is changing over here. Okay, All right. So in the next part, again, using these concepts, we are moving into the object detection part again under the computer vision. So we'll try to build a simple model, okay, that tries to classify the data. Okay, so we have another data set here. Directly we are downloading that into the machine. Okay, so simply run this part of the code. It's actually present inside the torch vision. Okay, so torch vision knows what do you, when I say CIFAR data, it knows what it is. Okay, so right, we'll run this part of the code. You can see it downloading, it gets completed, and now I'm actually trying to plot some of the data present over there. Okay, it actually I think this is 1 lakh images belonging to I'm not very sure how many categories we have. Okay, let me check ahead. 10 categories, I guess. Let me check whether I have plotted that. No, it's not there. It's not there. Anyway, fine. I'll find out. Let's see. Okay. Or if anybody knows what's the number of classes here, please let me know. Okay. I don't see the number of classes. Yeah. Okay. Definitely more than 1,000, I guess, because it's a huge data set, right? You can see the various. I think we are plotting only 60, right? So I'm saying that show the images, all images I0 for I in the range 60, right? One starting from 0 to 59, 6 rows, 10 columns. You can see that 6 rows, 10 columns in the plot here. Okay, then we are using a scale. I try to shrink it so that it fits into my window, right? If you have enough space, you can increase this more than 1. Keep it 1.5 or something. All the images will be larger. Okay, individual images will be increased in the size. Okay. So that's the visualization part, right? And now, so every number, again, every data set, whatever we see here, it's a colored format, but the machine does not need that information. You can actually convert them into tensor, right, by using a 2 tensor instance, right? So first one is, right, you see that I am bringing the horizontal flip, I am converting them into the tensor. Okay, so that is the training data. I call it as a train args, and test augmentation is once again compose, right, convert them into the tensor, because I don't want to increase my test data. Okay, you can do that, yes, but here I have not. Okay, so flipping and other operations, I don't want to do that of the testing data, only the training data we have. Okay, now, so in order to bring the data set into the memory of the computer, the PyTorch, we have to use what is called as a data loader, right? For that, I need to define where is my data set. It's actually located in a particular location. Again, this is the default location. If you go back, if you are running this particular code, in Jupyter, right, whichever folder you have been working for, right, there you get a new folder called data. Inside that, the downloaded data will be present. So this is actually root is equal to, in the current one, you look for a data folder. So from there, I'm saying, right, perform all of them, right? If you don't have, download it, right? And then I'm saying load that. Okay, so the data loader has to be used to load the data in case of the PyTorch. Now let's go for the say the training. You see, we are using the ResNet 18, right? We are very familiar with ResNet 18 now. It's one of the very standard or the state of art, right, neural network, deep neural network model, right? So this particular part of the code is actually for the training purpose. All right. So again, there is a modification here, right? Let us say we have GPUs present again, and now you are connected to GPU through uh, the Colab. So it's obviously required that you need to connect to that and you run it over the GPU instead of the CPU. So for that reason, again, this is the part of the code, right? As of now, don't worry about this, right? Because I don't think you have gone in detail about the PyTorch, I guess. that reason, I'm not going to deal this in very detail. Okay, so that's the code which we have to use it. And now, right, so I'll directly come to the training part of this. Okay, so try to run this part one by one. You run and you come to the last part and try to run this. Okay, train with aug data. That's the function which we have written here, right? So train arguments, sorry, train augmented data, test augmented data, the network which we have created, and specified learning rate, right? That's what I have been defined here. So it will run the codes, the functions which we have written previous to this, and it will perform the train. Okay, so we are using the previously used ResNet 18. We had defined that, but we have written that code for that over here. That ResNet 18 is the one which is the building block of our neural network, which we are considering over here. So it will run over there and it will show you this kind of graph. Okay, so again, various networks, we already have written the codes for different types of the standard networks, right? You can use any one of them and you can run the code. So here, only change that we have performed is to use the multiple GPUs if it exists. Okay, again, that's not required. So I just wanted you to have a code if at all you need that in future. That's why this part, devices equal to D2L try all GPUs is what is there, right? So that means any number of GPUs that might be present, right? Use everything, right? So in this case, only one GPU is connected because our Colab is free version. So only maximum one GPU is allocated. Also, if you are not using it, it will remove. Just now, I saw a message that popped up in my screen saying that you are not using a GPU, we are removing that. Okay, right? That's one part. Again, there is another concept called as a transfer learning. I'll just give an introduction to that. Okay, so that will be the last topic that we are going to discuss under the particular topic called as machine computer vision. Okay, so here the concept is that, let us say there is a model which has been trained to classify certain classes of data like tables and chairs. Let us say that's what is called as, you can see here, that's what is called as the source model. Okay, that's a source model, right? Then I want to build another model which I want to classify each and every type of furniture, right? For that, I can actually use this model over there. So you are transferring your learning from one model into the other. That's all, right? That particular concept is what you call as the transfer learning. So the idea is very simple, right? Just look at this, what you call, right? Just look at this image, this photo. There is a source model. This is something like we are training a particular network to classify tables and chairs. But I also have many other objects which I want to classify when it comes to the classification of the furniture. Okay, so this is the target model which I want to build. But what I do, right? All the basic layers of my trained network, I can copy them as it is because I want to classify these two for sure when it comes to the classification of the complete furnitures. In addition to that, only you see, right, the upper layer is there, right? This is yet to be trained because it's not just the classification of table and chair, something more. Again, in this diagram, we are showing only one layer, but definitely this can be many more layers because I may have to extract more features from the other classes as well. For that, you might require, right, more layers, right? But the idea is this: whatever you have learned already, right, just look at them and copy them to this. Okay, that's what is the first few layers. Maybe a fine tune is required. Okay, then there is what is called as the upcoming layers. After these layers, you may have to add a few more layers and you need to train them properly. Okay, let me close my session. I don't want to, or whatever. Okay, right. So this concept is what is called as the transfer learning. I have a model built. I can use the model directly for my next problem as well. Okay, so for a higher level complex problem, I can use whatever is already built, whatever is already trained, I can use it over there. Okay, so this concept is widely used in whenever you download a standard what you call standard ANN architecture, such as say the VGGNet or even the Google Net, right? You download, when you download, it means it is able to classify 1000 objects because it is already trained. But what I do, I want to add a new category to that, which is not present over there. Maybe my photo, because Google does not know who I am, right? I want to make sure that the one Google Net which I have is capable of identifying myself. So what I do, I'll take my pictures and I'll train. So what happens? The first few layers of that neural network still remains in, because I want to classify those 1000 objects which it already knows. Only the next part I'll add few layers and I'll train. Okay, so that's what is meant by the transfer learning. So below this, anyway, I have a code completely written over there, right? Take that as a homework, right? Please go through that, run that part of the code and see how it works. Okay, right. So any doubts so far?
So one like okay, yeah. So this transferring learning,
Yes.
is that something called? Can we say that it's a like okay incremental learning? So for example, my see in a real life scenario, we may be like okay, building building a model that requires like okay. Initially, you have like okay, maybe 100 object that you want to detect.
Yes.
Then you got like okay few more to like okay add it to it. So if I have to rebuild and retrain the entire model,
Yes.
it may take the amount of time might be like okay taken too high.
True.
If I collect, so will this help in that scenario?
Yes. It's going to help you in that particular, the direction in which we are going to use the transfer learning is the same thing which you are mentioning. I already have something trained, right? You don't have to train that part again. All right. So only whichever additional component which you want to add, additional classes you want to add, right? Only that part will be trained, right? So that should be very clear from this part, right? Train only that from the scratch. Depending upon slight modifications what you have, only those layers you perform what is called as a fine tune. Okay. All right. Any other doubt? Sure. All right. So that comes to the end of this particular session, as well as we are at the end of the computer vision module. All right. So please go through everything and let me know if you have any doubt with whatever we discussed in this particular module. And we'll meet tomorrow and we'll move on to the next topic. All right. So thank you. Thank you for being patient, and we'll meet tomorrow.